Hello everyone, my name is Daniel Montano-Lobe. I'm the current Structure Systems Manager, and what you're about to see is the 10th anniversary of the Akronauts Rocket Design Team. We held this event on November 26, 2024, and it was a historical moment for the team, bringing together 10 years worth of Akronauts alumni to celebrate the history of the team. Now, before we begin, I have two things to say. First off, I would like to thank every single Akronauts alumni, whether you graduated in 2014 and 15, all the way through present day, and the future as well. Thank you so much for all of your hard work and dedication. You have helped make the team what it is today. Secondly, below the progress bar of this video are chapters. When you click those, it'll allow you to instantly fast forward to whatever portion of this video. So, with that out of the way, please enjoy the 10th anniversary of the Akronauts Rocket Design Team. Thank you all so much, and go Zips.
All right. Good evening, everybody. How are we doing? For those who do not know me, my name is Daniel Montano-Lobe. I've been on the team for 4 years, coming on 5, and welcome to the Akronauts 10-year anniversary. So, for starters, thank you all for coming. We really appreciate you all being here, especially so many of you are coming from out of town. So it's really great to see so many of you, and yeah, we're just excited to get this show going. So, without further ado, let's get started. All right, so to the next proceedings, we're gonna give you a quick crash course of the past 10 years of the Akronauts. Then we're gonna have a word from our current team mentor, Dr. Manny. Then we're gonna have our first presentation out of 3. First is Akronauts. We have a mission presented by our co-founder, Batko. Then we're gonna have the Legacy Initiative presented by John Davis and Brian Dippolito. And then finally, we will have the Akronauts Now, which will be presented by our current president, Jonny Armbrust, and our current chief mechanical, Diffendal. Finally, we'll have some recognition of certain individuals and some thank yous and concluding thoughts for this evening. So, let's get started. So, we start at the beginning, of course, with Armbrust and the team's inception in 2014 and 15. So, Armbrust, named after the Greek personification for otherworldly darkness. I didn't name it, but really cool in my opinion. And, most importantly, this competed in IREC 2015. And this rocket was originally a 2-stage, but then it was last minute converted to a single stage with less than 48 hours. And I think that sounds really interesting, sounds really cool. To that I say, stay tuned for Jesse's presentation. You'll hear the full story. Next up, we have Dallas. So, this competed in IREC 2016, had an apogee of about 10,000 feet, and had a payload that had 2 GoPros that would record the desert terrain during descent for terrain modeling. It's very, very cool. And also this year is when we launched our Zaphod subscale. What's Zaphod? Glad you asked. Zaphod, in 2017, the name comes from the main character of Hitchhiker's Guide to the Galaxy. And this competed at NASA SLI in 2017 and won the Excellence in Design Award. With this, it flew with a payload designed to keep 5 clay pigeons alive and safe, even though they're just distant, not real pigeons, I promise. Though some teams also use eggs. And so yeah, that was a huge success and very, very good for the team, which leads us perfectly into another Z name. So we have Zion and Zoom. So the Zion competed at Spaceport in America for 10K cots, featured carbon fiber wound body tubes, and housed a fold-out Mars habitat, which is super cool for the payload. If you noticed over there by Zion, we had that PLA section, that's like a square section, that's where the payload sat in. And unfortunately, this rocket did not fly due to issues with our igniters, but we still love this rocket all the same. Super cool rocket. We also had Project Zoom, which is a senior design rocket that was shown and presented at Spaceport America for 30K. Next up, 2018, we had Lazarus. So it competed at NASA SLI 2018 and won the Excellence in Design Award. Unfortunately, Lazarus had an unsuccessful flight due to ejection charges that May, and it ended up in the ground. Now, I think it's pretty sad, but there's a happy spin to this story. So, after the wreckage was pulled out of the ground, the team noticed that the ZAR in Lazarus was missing, or at least mostly squished. And what was left is Laos, and that became Spaceport for that year. And so Laos was basically built upon the the technology that was already in Lazarus, and we brought it to spaceport. It was fantastic. And that same year, we also did the Estrella subscale, known as the Little Dipper. It's the little blue one over there. So in 2019, we then launched the full-scale Estrella. We brought it to NASA SLI in 2019, and we placed third. It was awesome. And we also launched the Pencil rocket, which competed in IREC 2019. And the rocket then, after this, found new life being repurposed for Emergence 1 and the ISL test rocket, which you'll hear more about later tonight. And it's also at this time that we launched the subscale for our rocket called Project 22. So when we did the full scale of Project 22 in 2020, at this point we're getting to our COVID years, this competed in NASA SLI and won 4th place and had a gorgeous candle paint job. And then we also started Project BOGO, and we had multiple subscale launches with Project BOGO. And again, it's another thing you might be wondering, what's Project 22, what's Project BOGO? And to that I say, stay tuned to our second presentation with John and Ryan. So, moving to 2021, we had 2 more subscale launches for Project BOGO, with the 3rd being fully successful. And then, finally, we began the Emergence series, which are a solid propellant, SRAD, space shot series. And we started with Emergence 1, and featuring our new SRAD propellant, Angulus 3. This rocket flew to about 14,000 feet and hit Mach 1.2. And again, this pencil rocket was then repurposed one more time for our ISL test launch rockets. Now we're at 2022. Emergence 2 is launched. It's the first supersonic rocket to fly in Akronauts history, sub-minimum diameter motor with an external fin can squishing onto the top of that motor casing. Flew to 22,000 feet and Mach 2.1. It's a beautiful burn over there. Then, in that same year, we had the I Promise rocket. So this competed at Spaceport 2022 in 30K SRAD 2-stage, and is built in collaboration with the LeBron James I Promise School. And this also won the Jim Fafaro Award for Technical Excellence. It is the very tall one right there. Move on to 2022, and we have our first liquid engine hot fire. And so, history for the team right here, and history for collegiate teams in the state of Ohio. And you'll see more of these hot fires coming up. Then we had Emergence 3 in December of 2022. Another 2-stage fully SRAD solid propellant rocket, flew to 38,000 feet, and it was the first variable diameter rocket in Akronauts history. So we switched from 6-inch diameter to 4-inch diameter for our second stage. So first time in our history. Finally, we move on to 2023, and we launched Imperium 6. It's competed in 30K SRAD, Spaceport 2023, and we got 2nd place in our category. And it is at this point that development and integration began for 4 whole rockets. So buckle up. 2024, very busy year for us. We had, firstly, our ISL test launch. So this is the Pencil rocket, version 3. This rocket is meant to test our payload and avionics components, so we don't have to risk damaging them on a full, larger scale flight. We can instead do smaller scale flights here in Ohio, and using our modular connection technology, just swap out the bays and reload the motors and launch them whenever we need. Unfortunately, we did have an issue with sealing on our drogue bay, so in this particular launch, the rocket came down pretty hard, but at the same time it was a positive because it showed that our payload would withstand essentially falling down ballistic. So, next up, we had Venom Launch Vehicle. This is powered by nitrous oxide and ethanol and flew to 10,000 feet. Also featured the team's first tip-to-tip layup, so fiberglass fins and laid up. And the first liquid propelled rocket by a collegiate team in the state of Ohio. Huge moves for the team, and it's definitely not the last liquid propelled rocket we're going to do. Still in 2024, we have Emergence 4. So another 2-stage SRAD, this time 6-inch diameter all the way through, and still featuring our tungsten module, which is essentially our big aluminum interstage couplers that we have there and there. Unfortunately, even though this did fly to 55,000 feet, we did have stage separation failure, and the motor ignited while still attached. However, still 55,000 feet is a record for the team, and it's a record, although we were very happy with it, we do intend on breaking this record this year. Finally, we have Project Eric, right here. This is our last spaceport rocket from this past summer, competed in 30K SRAD 2-stage. Fortunately, we had another failure, this time with our COTS motor, but we placed 2nd overall in 30K SRAD for our technical report, and fifth for build quality. So the way we looked at it is, okay, if we didn't have this cost failure, then our placement could have been much more than we could even imagine. And that's why when we go into this year's space work, which Jonny and Eric will talk more about, we'll see that this is more of an evolution, and we're definitely not leaving Project Eric behind. So, with that in mind, before we move on to our three main presentations for tonight, and now that we've finished our little crash course, I'd like to first allow our current team advisor, Dr. Manny, to come up and say a few words. We'll continue the show. Thank you guys.
Hello everyone, my name is Manny, and first and foremost, I want to thank all the people who are here, and especially the older members who made this happen. And I became the advisor like 2 years ago, 2.5 years ago. I'm the third advisor, I think, for them. When Dr. Locke left, and he called me after that, and I became the advisor. And the first thing, like when I became the advisor, like 2 weeks after that, they were leaving for their emergency launch, and they needed a car at that point. And it was like ever been like every time I get a message from them, it's something bad at that year. It was kind of crazy, because after that we went to spaceport, and that's the first time I'm going to spaceport, so I was also driving. And but 4 hours into the drive, I get a text and a call from Dale and Josh saying that they lost a tire. And they're in the middle of Indiana on a Sunday. So there was no place they could change anything on that, and they had the rocket with them. So they somehow found a place where they bought tire for $40 cash. I still don't understand how. And 2 days later, we all reached, and when I was reaching my hotel room, Dale is there in my parking lot with 2 people with COVID. And I'm like, okay. And it's good that I booked a hotel room which had 2 rooms in it, so they could stay in the other room. And that night I had to go and find every COVID test that I could find in the whole town. So we bought like $1,000 worth of COVID tests, and then made everybody test. And because every day 2 became 3, 5, and at the end of the day it was like 5 people. And it was a great experience in the sense that there were 28 people in that year that they came to spaceport, and everybody was helping each other, and they were building this rocket in the middle of nowhere. And one more story. Emily texted me the second day I was there that they are floating at 3 in the morning, that it rained so bad and everything was floating. And I'm like, at 4 in the morning, I'm looking at hotel rooms to book for them. And most of them went probably into their cars and slept in their cars. And they were sending me pictures of all the scorpions they could find and all those stupid things that was making me pretty much kill them, but I didn't. After that, that was the year that they launched that Akronauts Rocket. They were the talk of the town, and they were the celebrities in the town because they were also the tallest rocket. And it was crazy because everybody wanted to ask us how we did this, what we did in this rocket and all those different things. And it first and foremost put our name in the Spaceport Hall of Fame right now, I would say, because we will be there soon. And after that, they had the emergency launch again, and thank God that didn't happen anything at that launch, I guess. So that was a good thing. And after that, that's when they started working on the liquid engine, and they wanted to test fire or hot fire it, and I was like, did you guys talk to the safety department? And their answer was actually no. And we had to stop them, stop everything, and have a whole full-on meeting with the safety to get everything cleared before we do something stupid. Which pretty much should testing that liquid, hot firing that engine in the middle of farm was something stupid. But it was great to see. We had amazing time over there, and we made history. We beat OSU and other big schools in this area by becoming the first student-built liquid engine that we tested. And that became the boost for the university. We started pushing for more funding. Till then, they did that student rock, the Armbrust rocket. I think they had $12,000 funding for that whole year. They had like $12,000 funding for it. And after that, it went to like $35,000 the next year. And then the following year, it went to $60,000. And this year, it's at $75,000. They got 1/3 of the entire department, college's funding this year. And that's how much they've grown, not just in their quality of rockets, but also in the size. There are like 40, 50 people when I joined, and now it's like more than 100 people. Well, there's 200 people in Discord, I don't think they're there, but there's like 100 people, and that's how big they've become. And now they have their own emergency series, which they are trying to reach space, and they have the liquids, and then they have the spaceport competition. And the next year in spaceport, I think they're not even going for the 30,000. I think they're going for the 45,000 competition. So they are just raising the bar every year. And I'm so proud of all these students, except when they call me with their problems. But that's probably the job of an advisor, I guess. It was, every time this time when they launched their rocket, I was actually in London in a conference, and I was watching it on my phone, and my wife was like, put your phone down and watch where you're walking, pretty much, because I was actually walking somewhere at the bridge or something, and I was watching their live feed. And also that was another funny thing where there's Eric sitting. They started calling me because their the tires of their trailer broke like twice, and they were like asking for my credit card when I was in London for them to buy 2 tires from Tractor Supply. And I'm like, you guys, I have 200 minutes, and I spent more than 100 minutes just on them from the conference. But I love doing this job. I support them in everything that they do, and they do a great job. And I'm really, really proud. And they go big places after they graduate. They all go to NASA or somewhere big. And it's great to see that happening to each and every one of them. Even though I try coaching some of them to be masters and PhD students, not that successful, but I'll try becoming successful later. But I'm really proud that this team is going to grow big, and they're going to be the top of the town. They're already the top of the department. They're going to be the top of the college, and then the top of the university pretty much soon. Thank you all for coming. And next it will be Jesse, who will be talking about the first ever rocket, and he started all these, so I have to blame you for all this. And pretty much, and thanks for doing that, for starting this 10 years ago. And everything that we do is because of you. Thank you.
Yes, I have a speech. I don't normally do this, written, but I had recalled 10 years of memories. So we're going Hello, my name is Jesse Batko. So I'm a 2010 graduate of High School, as well as a 2015 graduate of University of Akron with a bachelor's degree in mechanical engineering. Upon graduating, I received a position at Purdue National Accelerator Laboratory working on big science projects. Today, though, I'm a principal mechanical engineer at a startup company called Commonwealth Fusion Systems, which is a company trying to commercialize fusion. However, my largest and greatest contribution and achievement is being the co-founder and president of the Akronauts Rocket Design Team. And this evening, I'll be sharing with you what led to the creation of the team, challenges the team faced, and successes we achieved during that first pivotal year that gave the momentum trajectory of the team to what it is today. All right. The origins of the team was actually a result of a late night phone call. It was between a friend of mine by the name of Kenny Wainsmith Jr. He was also co-founder and first president as well. It was junior year, and we were discussing potential senior design projects. We brainstormed ideas anywhere from fusion to cube satellites. Fusion seemed a little bit out of our wheelhouse, but cube satellites seemed a little bit more achievable. We looked at programs where you can buy a CubeSat kit and apply for a chance to launch on a NASA rocket. However, the kit was expensive, and even after purchasing the kit, the chances your CubeSat would be chosen was less than 10%. One of us said, with those odds, we might as well just build our own rocket and launch our own payload. The rest is history. The next few days, we met with our friends, kind of looked at what kind of competitions existed, what universities had rocket design teams. And by the following week, we were sitting in our favorite professor's office, Dr. Francis Loth, asking questions about the process of starting a team, as well as if he could be our faculty advisor. We set off with meeting with university officials and the student body government to put in the paperwork to start a new club. It was then that Kenny came up with the name of Akronauts. So with a name as great as that, we knew that this team would have to be also great. So with the paperwork submitted, the name picked out, we posted flyers, and it's actually this very flyer that we posted all around the university. And we also sent out a mass email to the student body, both graduates and postgraduates, about the new design team, as well as the time, date, and place to meet for the new member orientation. At this time, the team was less than 10 members, so it was practically just our friend group. But we had no idea the interest that it would generate. By the time the meeting started, every seat was filled with interested students. There were students lined up on both sides of the room, as well as crowded in the back. Just to kind of give you an idea of what some of those numbers were that first year. Now, this was just from the student roster. Our active students were actually more like the 40 student count, but we had 8 officers, 11 system leads, and 108 total members. And that also included our advisor, Dr. Loth. So, with the meeting behind us, little did we know the trials and challenges that laid ahead. And I'll briefly cover 5 of the main challenges that we had to overcome. So challenge 1, team engagement. This problem intensifies with a larger team. We decided to take the approach of splitting the team into smaller sub-teams where team leads are responsible for specific systems on the rocket. These sub-teams were propulsion, guidance, recovery, payload, structures, launch pad, and electronics. This allowed the team to work on the rocket while the officers figured out the next challenges. Challenge number 2, design space. The team needs space to meet, build, and conduct business. Luck would have it, during the first team meeting, the last 2 members of the human-powered vehicle showed interest in joining the team. Upon hearing we were looking for a space, they offered their design space to us. We immediately moved in and cleaned the space out and got ready to build our first thing as a rocket design team, our K-12 air cannon to launch student-built paper rockets. But little did we know the university had plans for that room. A new faculty member joined and they wanted to make that their office. We once again found ourselves homeless, meeting in rooms around campus, as well as walking around campus, trying to find those rooms. We spoke to our faculty advisor and together pleaded our case to the university that a team like the Akronauts needed a home. After some conversation, we were offered 2 alternative spaces. One was a few rooms in the Quaker building, and the other was a double-door room in the Student Design Center that was right next door to the room that we briefly had. Both of these options, though, had stipulations. The rooms in the Quaker building were for team meetings only. There's to be no building of any kind. The double-door room could be used for building, but would not be a permanent space, as this room was used by any contractors who did work at the university. We decided to give up on the Quaker building as it was off campus, which led us to use the double-door room. And this is actually a picture right after we outfitted it. This is how basic and simple it looked compared to what it looks like today. Immediately, we went to the university surplus to outfit the room with chairs, whiteboards, filing cabinets, tables, and the infamous white couch. You can kind of see it there in the corner. Challenge 3, funding. Funding is always a difficult aspect of a project. We did not have a track record to run on, and we did not know how much money we would need to build a rocket, nor how much money it would take to run a team. Our goal was to raise as much money as we could to cover our bases. While we were pursuing different avenues of funding, we learned about another design team's attempt to take us over. This team, which I will not name, believed that we should be an extension of their team and that they should be the governing body. We decided to just ignore them. This team then continued to talk to other design teams, trying to tell them that we were going to take money away from everyone else. I mean, it kind of sounds like you guys are doing that now, but back then, not so much. It was nuts. However, through all this, the president of the well-established team, which I also won't name, took us under their wing and helped us prepare a proposal for funding, reviewed our paperwork, and helped strengthen our message. It was the kind of support we needed. While at the proposal meeting with university leadership, Kenny and I gave our case, and the team that wanted to take us over made the following comment in front of everyone. They are a new team without any history or success. Why are they here? Before we could say anything, university leadership stated that we had the same right as anyone else to be there, and the fact that no team will lose money because of us. A few weeks later, we were informed that us and every other design team received their requested amount. We never had issues after that, and that team that disliked us ended up actually being very supportive of us later on. The university was one avenue of funding, but we had many others. They included the Ohio Space Grant, co-op employers, candy bar, and Chipotle fundraisers, to name a few. In the end, this team that had no history raised just shy of $30,000. Challenge 4. We had the personnel, the space, the funding to make this project succeed. There was just one problem. How do you build a rocket? This became increasingly apparent as system leads started having meetings. The passion was there, but we were missing the knowledge. During this time, I was interning at a company that contracted with NASA to design and build experiments for the International Space Station. My mentor at the time learned about me and my rocket design team and suggested I get in touch with a friend of hers who would be able to share her knowledge of rockets. Her friend led us to a man by the name of Chris Pearson. Chris Pearson has been there since the beginning, helping all aspects of the project. He brought one of his rockets in to show all the components. He taught us how to make solid rocket fuel in one of the university laboratories one night. And FYI, the guy in the bright green jacket was Akron's safety officer, so we did talk to the proper people before doing this. And then a few weeks later, test that same fuel via a static firing test at a remote farm. Chris's knowledge and time has become one of the greatest assets our team had that first year. It brings me such joy to see that he is still advising and helping the team 10 years later. The fifth and final challenge we had to overcome was time. It especially felt that time was not on our side. Since we were a new team with a new account, it took a while for the money to become available, which delayed things. Members were spending their own money to buy hardware to continue the process. We did end up reimbursing them at the end, so don't worry. The team also took the classical approach of being a college student and built the entire thing in the last few weeks before the competition. This time in itself was tricky as graduation had just happened and we were losing a lot of our recently graduated members to their new employers. I, unfortunately, was one of them. Regardless, the remaining members stayed steely-eyed through those last few weeks and brought the project from about a 15% completion to a 95% completion. So this was on May 20th, about a month before competition, and about probably a week before I left for my job. You can see about 2 weeks later, we had negative progress. Still nothing. But then, a couple weeks later, we started actually getting machine parts fitted for the first time. This was our fuselage, our body, some bulkheads you can see there. And then, basically, 2 days before we left, we did our first fit check of the rocket. And then after that, we call him Danny Van Gogh, painted the rocket all by himself. And then, Danny Van Out. He kind of stayed there the whole night, and that's kind of how the couch got the infamous name, because I think the team got in trouble a little bit later because of having the couch, so we had to get rid of it, I was told.
Your bed still has it.
Who still has it? Nice. All right. So the only thing left to do between us and making history was a 26-hour car ride from Akron, Ohio to Green River, Utah to compete in the 10th annual IRAC competition. The journey out west was such an amazing experience. A team that did not exist a year prior was driving the student-built rocket. The rocket was a 2-stage solid motor engine, which we named, and we pronounce it Erebus, which is which in Greek mythology is the personification of darkness, the offspring of chaos, and a key figure to the origin of the universe. I don't think we could have picked a better name for this rocket. This rocket had our blood, sweat, and tears, but the funny thing was we had no idea if it was going to work, as we did almost no testing prior. The most testing we did was the spit check, and then also our payload airflow test outside our car window. And somewhat successful ejection test of the parachute. I say somewhat because of this.
All right. Ready?
So, yeah. A lot rode on this team. If it was going to succeed with a launch to the heavens or go out with a bang or a whimper on the launch pad. I wish I could say the competition went smoothly, but Project Erebus had to live up to its name, especially the chaos part. Beside a flat tire we got hours before the launch, we failed our pre-flight safety check due to the fact that we did not have a redundant power supply and a computer system. This led us to combine the first stage power supply and computers with the second stage, reconfiguring the internals so everything fit and make sure the center of gravity was still safe for rocket stability. Probably the most impressive aspect was our electronics team spent the next 24 hours straight recording everything to ensure both systems talk to each other. We missed both our flight windows because of this redesign and we were no longer in the competition to score. They allowed us one last chance to launch on the last day at the very end of their launch window. The organizers of the competition learned that we were a brand new team and they learned that they wanted to see us launch. However, while on the launch pad, our nose cone fell off. This was due to the adhesive that we used to do a pressure fit between the cone and the body, but it failed because of the heat. This day was 132 degrees. The launch judge saw what happened, turned his back, kind of like this, and was holding a roll of duct tape. We grabbed the duct tape and proceeded to tape the nose cone back onto the vehicle. Finally, with the rocket on the launch pad, our last igniter in place, it was our last shot. We knew how important it was, not only for the team, but for the future of the team for Erebus to launch. Sitting patiently in the complete silence of the desert, we looked to the rocket as the countdown came to 0. Nothing. But then, we had ignition. The rocket went into the sky until it was out of sight and the sound of the engine faded while cheers from the crowd emerged. Parachutes deployed near Apogee, which wasn't good, causing a few tethers to fail and the rocket to make a rapid descent. However, the rocket, being as well built as it was, landed within 100 feet of the pad with nothing but a few scratches from landing. None of the computers recorded any data, but we did not need the data to know that it was a success. And thus was the conclusion of the first year of the Akronauts Rocket Design Team. Thank you. Our next presenters are John Davis and Ryan Dippolito on the Legacy Initiative.
All right. Oh, is it like a thing? So when you're done, switch the slideshow. Noted. All right. Cool. All right. Hello, everybody. Hope you're happy to see us again. Here we go. Oh, maybe not. We're almost good at this.
It's not rocket science.
Yeah, it was. All right, cool. So, hello again. We'll redo the opening now. So in short, for this slide, one of the things is we're going to try and kind of breeze through a couple of the things that we did. That way we're not redundant. That's what but this is our agenda for the day. We'll be doing our introductions. For those of you who don't know us, get to know us a little bit more. For those of you who do know us, yeah, hi. Okay, so then we'll go over the state of the team, the multi-pronged approach we used to evolve the team, some of the results that we had during our tenure, and the impact that had on team budget, member employment, because as you all know, it's basically a job, and then lessons learned during our time and the closing.
Cool. So, my name's Ryan Dippolito. I was on the team for 6 years. This past spring of 2024, you can see some of the positions I held. The one thing I really wanted to have on this slide is not just a picture of me, but those 3 pictures of me and John in the middle. I think one thing all of us like to, that have been on the team for a while, really something that doesn't get stated a lot. We get a lot of friends from this team. We get a lot of lifetime friends. Both me and John got future wives out of this team, like a lot of people do. You know, it's pretty amazing. And those 3 pictures just culminate a lot of the times me and John got to spend together. That's the same for a lot of you guys here, and I just want to say thank you for the opportunity to make a network here at Akron. Moving on to...
All right, cool. This guy's working.
Oh, that.
Hey. All right, cool. So yes, that was sweet. Thank you. That was very nice. I'm Jonathan Davis. I started out on the team, on the recovery team. Did a little bit of payload stuff and then media. I was one of the first people doing the stuff you see in the back. Well, not really, actually. We got right there, Hannah did a whole lot before me. There's some videos in the Akronauts Drive. I encourage you all to go find it. There's some cool stuff in there. Really epic things. But that year, I took a camera to NASA SLI and used it. And I encourage you all to do the same who are still on the team. Because a story that goes untold is a story that goes unknown. That being said, I was vice president for a period of time, then project manager, safety officer, project manager. Probably stuck around a little bit longer than some people wanted me, and not long enough for others. So, okay, next. Yeah, we'll jump into state of the team. That's got Jay in the top right. That means I do it. Okay, cool. So, state of the team in 2018, 2019. This was kind of when Ryan and I were getting used to the Akronauts, learning the ropes, and finding our places on the team. Stuff that happened that year. Well, on that note, we were serving at that time underneath Lucas, Repa, Adam. We were members, and we were trying to kind of come up in that environment. And that year we had the NASA Student Launch Initiative, and that was Estrella that you can see up there on the top right, and right there, very beautiful rocket. That rocket actually had a couple of other awards that went to it, I do believe. For anybody that was there, please correct me if I'm mistaken. But there was 3rd place in the overall category. That's what everybody remembers. It's pretty cool. But there was also, I think, 2nd place in best looking rocket. Is that true? Second? I think it was second. Lucas doesn't look like he remembers. Okay. And then first place, I do believe, in the outreach category. That was a year, actually, that Thomas Cobb, who used to be on the team, made his senior design project was outreach. So if you ever hear anybody say that they don't like outreach and don't want to do outreach, you make senior design. Spaceport America Cup that year was the initial launch of what we now know as Emergence 1. Back then it was the pencil rocket, and it had the name Space Force 1, I do believe, because that was original. And I think there was a little bit of argument, but it won the voting, so there you go. It was in the it was fully SRAD in the 10K category, and had a 360-degree camera system. And that got honorable mention. And that was actually probably one of the coolest moments on the team, because the rocket went up, and it looked like it was going to orbit, because it kind of flew sideways, which was interesting. There were definitely some really calm conversations after that for why it did go sideways. But it was successful, the motor worked, so that's also a note. And did not blow up. A lot of other ones did blow up. But when it was going sideways, it kind of reached apogee. So it decided it was going to deploy the payload and deploy parachutes. And then that payload came out going, I don't know how fast, but very fast, and then fell literally directly in front of the spectators. So us being the Akronauts that we are, we decided the most logical thing to do was run out onto the launch field and get pictures. And they didn't like that because the launch field was still hot. So for those of you who are still on the team, don't run out onto the launch field, even if something really terribly epic happens and you just need the picture. Yeah, it was a beautiful day. Anyways, preliminary basement meetings. Charles, big shout out there. Charles had that senior design that year, and that was the birth of Venom. So I'm sure, Charles, you really enjoy seeing Venom back there in its full glory. But back then, it was, as was said before, right? We didn't have those conversations with safety. We were kind of worried safety was going to say no, and we want to get something on paper before they told us no. So we were just kind of sneaking off into the ASEC basement and drawing some stuff up. And then Charles made the least controversial image ever in Akronauts history, put us all on Mount Rushmore, and that was very well received by all other senior design projects that year.
It was like 3 a.m.
It was 3 a.m. One of those Elon tweets, okay. Next slide. With that, we'll jump into the multi-pronged approach, and we'll all look to the top right and see if there's an R or a J.
There's a J. That's you.
Oh, there's a J. Okay. Long-winded, it seems. All right, here we go. All right. Cool. That's why they make these without cords. Cool. All right, here we go. So, the three-pronged approach of the Legacy Initiative. I'm going to come down here so I can actually read it. Okay, so the first question we had was, how do we garner more media attention? We'll see what pops up next. Okay, we're gonna answer all the questions first. So, 2, how do we push the technical capabilities of our team and put the Akronauts in the same category as Purdue, USC? You know, you got people who are launching rockets in space, you got people who have professors that are like testing hypergalls. It's just insanity out there. And we're meeting in ASEC basement, you know, putting stuff in PowerPoints and whatnot. How do we get on their level, right? And then third question, how do we serve as a platform to train students for the aerospace industry and make it easier to gain employment? One of the biggest things is, you know, everybody who started this team, right? A few got really good spots. I don't know the stories of everybody, but I do know that everybody that came after that kind of had that vision. I want to get into the space industry. And this was the method by which to do it. I, for one, came to Akron literally only because the Akronauts Rocket Design Team existed. Anybody else, is that true? All right, and the hands go. Okay, so from there, how do we garner more media attention? Purpose-fueled missions. People, 1, they like a good story. 2, you have a platform. It's a good idea to use the platform to try and make some good in the world. How do we push the technical capabilities? We need independent technical innovation. You know, that seems like a bunch of buzzwords, but it's true. And then, how do we serve as a platform? Well, the 2 most important things there are you need leadership expansion. You need people to be able to put on the resume, hey, I did a thing. I held a role. I was a leader. And you need higher launch frequency. Higher launch frequency was also accepted with wide open arms immediately. It's a bit of a joke. No, people, that's okay. At the time, it was a little contentious. But the general idea behind it, I don't think I spent a lot of time back then explaining the ideas behind some of this stuff. The general idea behind it is, if you have higher launch frequency, people are able to put more things on their resume, right? It seems really straightforward now that I'm saying it out loud, right? You put more things on your resume, you contribute to more things, and then you go into your interview and you talk about it, and that makes you stand out from the crowd, right? Cool. So, all of that leads to increasing our overall team budget and impacting the students at the University of Akron, which are the two most important things to make this team awesome. So, next slide. There's not a J or an R, but this looks like me. Okay, the purpose-fueled missions. So, continued dedication to student development and achievement at the highest level. That's actually a thing Emily and I wrote in one of our meetings back in the day. One, we had a 4-year plan to build actually, is there anybody in this room that, like maybe Lucas or somebody, Adam, do you guys remember me presenting this slide, but it was blue? Does it look familiar at all?
Yeah, I remember.
I had to present it in the basement to try and get people on board with the idea of doing the legacy initiative, and it worked out, because you see the rockets over there. But one, it was a 4-year plan to build upon team identity and legacy, so identify that which was done before we showed up, kind of commemorate those things, and then create narratives that allow us to do the next phase, right? But keeping it all intact. 2, banners. We made banners. They're not as good as those banners. So good. Way to go. 3, Project 22 had a soft deadline, and the I Promise project had a hard deadline. Now, I was actually, so I was in the Army for 6 years, and so these are both kind of my brainchild. It was in 2014, I believe it was 2014, it could have been 2012. It was found that 22 veterans a year were committing suicide. And there's a whole lot of the number 22 in the veteran community and initiatives centered around that. And so at this point in time, we were like, okay, first thing, Project 22, we had a preferred launch year for it, but let's try and make a rocket that commemorates this and raises the level of conversation for the veteran community that's in this area, and also support some other things that were happening at the Out of Darkness Walk and elsewhere that year. And then there was the I Promise project. I was actually having a conversation with, I'll say a mentor at the time, about some frustrations I had on the Akronauts, as many of us likely have done. And in the course of venting all my frustrations that I was having at that time, I was like, we're the only team in Akron, we're the only ones who can like do something with LeBron. Why can't anybody see that? And then my mentor said, you should write that down. Write that down. And so I wrote it down, and then put it into this presentation. And everybody really liked the idea, and it really panned out. It became bigger than I ever really imagined possibly could. And it happened on a quicker timeline, which was really cool. But this was kind of like the initial, hey, we're going to name this the Legacy Initiative, let's identify what we've done, and get somewhere even beyond what we've done. So that kind of sums that up. And now, back to our slide.
Cool. Yeah, so then one of the things that we also realized is we wanted to push ourselves to be up in the upper echelon of collegiate rocket design teams, like in the same categories that Purdue, for instance. We needed to exist outside of the competition structure that we were currently in. So like when we were first on the team, it was very much, the team had done well to, I don't want to go as far as say mastered, but I mean to us it seemed like we had mastered the cadence of NASA SLI in March, a spaceport IREC in June. And the team, what we didn't want is we didn't want to remain stagnant in that space. We didn't want to just like keep building similar rockets year after year. So we decided to start some new projects. Now when I say start some new projects, that also means I guess push resources more primarily towards outside projects outside of competition. So that starts with the Emergent series. That's kind of where that came from. We realized that at the time, USC was the only collegiate rocket team to put a rocket in space. Now, they had like $50 million or something, so that's not really fair. So we figured that we wanted to be one of the teams that could help break past that line as well. So the interesting thing that we decided is we said, okay, we don't have $50 million to build a big, huge rocket and have a bunch of help from industry and all those types of things, right? So we decided to take the approach of doing iterative design work. So we said, okay, let's start this emergent series. Let's say it's the goal of eventually the Akronauts reaching space. And let's just start by building 1 to 2 rockets a year that are with the goal of going higher and higher and higher and higher. And kind of emulate the cadence of, you guys see like those SpaceX, like the Starship launches and stuff. They seem like they happen once a month now. They're super cool. We wanted to emulate that kind of, high stakes timelines in our team. We felt like that was the most productive. In addition to that, the liquid engine program, when I say starting the liquid engine program, it wasn't like it was already kind of in work at that point, but we decided, the executive board decided to really push a lot more resources towards that and make it one of our flagship projects, because all the best rocket teams in the country were working on liquids. In addition to that, liquid propulsion represents probably the lion's share of the aerospace job market, and our job as a rocket design team, for most primarily, is to train engineering students at the University of Akron. And having a liquid engine program puts our students in the best position to get jobs in the aerospace industry as possible. So, and then in addition to that, having a lot more increased focus on the Spaceport America Cup. Now, I don't know how it may not have always been the case, but it at least felt like in our first 2 years in the team that NASA SLI really took priority because of the extensive report writing that was involved in that competition. And IREC was always like scrambled together last minute after all of the hard work in the NASA SLI competition was over. So in 2021, we decided to get rid of the NASA SLI competition, not just to focus on emergence and liquid engine, but to be able to focus on a competition that we felt allowed us to innovate more. So this is a J slide.
Oh, Roger. Okay, a J slide. This is probably one of the more interesting decisions that happened and kind of how it came about. But primary thing is serving the students. One of the big things that Emily and I are having a ton of conversation about this at that time is like, okay, who's our customer? And the Akronauts got really into the mode of the customer is NASA SLI. You got to make sure that your report is perfect. You got to do all those things, and that's really important for training yourself and training others around you to be really good engineers. But one of the things when you're leading the rocket design team is the people who are actually getting the product of sorts are the people who are coming to the team, right? It's that team engagement. The most valuable thing that this team is offering is experiences for all of us, right? For all the people who have had an opportunity to work on these things. So with the new expansion of team programs and an increase in team population, we needed an expansion of leadership roles. That's a little reverse. I think this is probably the nicer narrative to it, right? But what we actually did is we plotted on a graph each year the number of, quote unquote, leadership roles, active members, and your non-active members, right? And what we found is that when you're looking for active members, and it'd be interesting to see if this is held true since the team really blew up in size. But what we found is that a coefficient of 2.8 to 3.2 could be multiplied by your leadership positions to understand how many people were heavily involved on your team. Your ratio was awesome. That first year, wow, But with that in mind, we decided, okay, we're going to change the structure of the team from this executive board with leads underneath. We're going to open up system manager roles and allow the systems managers to have a higher stake in leading these individual groups, expand the number of teams that are underneath the systems manager, and then have the systems managers and the executive board work together to accomplish goals. And through that expansion, right, if you have more people, more projects, okay, more projects, you get more leaders, and with more leaders, you get more opportunity. Because that, for every person who gets a leadership role, that's the thing that they're putting on the resume. And all of you know this, who've held leadership on the team. When you write aerostructure member on your resume and you say, I helped with this thing, it hits a little different when you write aerostructure lead on there and you say, I led a team of maybe even just 4. I led a team of 4 in the construction of a tip-to-tip layout. It hits different. And now, when you sit down for that interview, they want to know, okay, what was that leadership like? Can you tell me a little bit more about it? And now that's the thing you're talking about in your interview. Or at least that was the case for me. So, we set a new goal of launching and hot firing 2 to 3 times a year, and that opened up opportunity as well. But this was kind of the idea behind it, and I want to reiterate before we move off this slide, because I think it is genuinely probably the most important lesson that I learned during my time on the team. The true customer is the student, and I hope everybody from the university loves that, and I hope the people who are at competitions love it too. But really, we have a duty to each other to try and help each other in our successes, and this team really is doing that for a number of people. Pretty much everyone in this room, for the most part, right? So we'll move to results from 2019 to 23. We're going to blow through this as fast as we can. You got it pretty good. Okay, so year 2019-2020, I told you a little bit about the Project 22 rocket. I told you about the 22 soldiers who were found to be, not just soldiers, but service members who were found to be committing suicide annually in that infamous report. But this rocket, and this is one of the things, so a lot of people don't know where these rockets sit. That little black rocket over there that has the military insignia on it of that kind, the Space Force was not there yet. Now the Space Force is there, they need to be added. That rocket sits in the Military Services Center, and every veteran that comes to the university and has to interface with the VA sees that rocket and they hear about the Akronauts. So that's one. Two, the other rocket, the larger one that has the 22 on it, that one sits in the Veterans Lounge at InfoCision Stadium. Ironically, tangentially to the I Promise Institute that's up there on the 3rd floor as well. But every veteran that goes in there, of which there's a number, including myself, goes in there, and that rocket is displayed next to an American flag with its own spotlight that shines down on it. And people come in and they ask about it, they hear about the Akronauts. One of the things that I want to do is get some plaques for them, put them in that space, because both of those rockets were actually flown in memory of Sergeant Ryan Baker, who was a sergeant in the United States Marine Corps. You can see, if you look at 1989 and 2015, he was not very old when he died. He struggled with PTSD upon returning from Iraq, and in 2015, regrettably took his life. And his mom was heavily involved with the team that year when we were doing the Out of Darkness walk and going to Victory Farms and trying to be involved in veteran suicide awareness. And she wrote up a beautiful story about Ryan's life. And that story was talked about in a lot of veterans publications. It kind of be interesting to see if some of the leadership today has ever seen those veterans publications that talk about the Akronauts, but that was dispersed all across the nation. So that gives a little bit more background to this. This was also the year of the onset of COVID. And COVID hit, and then we weren't allowed to go to school anymore. Everybody had to move online, and things got real weird. And then we moved to the Rocket Garage, and there will be more on the Rocket Garage later. For those that don't know, Jim and Jill Armbrust in the back, Emily and Jonny Armbrust's parents, they were kind enough to open up their home and allow us to use their garage while maintaining 6 feet of distance, please social distance. And then we were able to get a lot of our builds done then. So that's Project 22.
Cool. I can talk this like I talked a lot. Okay, cool. Okay, so moving into the next year after that, as part of that technical innovation, specifically focusing, Project 22 is our last NASA SLI rocket, but moving into, I guess that same year, we focused a lot on building a 2-stage rocket and trying to make it successful, specifically as Project Batko. That was gonna fly at Spaceport that year, but then COVID happened and it ended up getting pushed back. We ended up pushing it back to I think October of that same year, and we ended up launching it ourselves at the Friends of Amateur Rocketry site in Mojave, California. Now, I would say the biggest reason that this is on here, and the biggest thing I want to talk about, is that this was a pivotal moment on the team. We had a lot of seniors graduate with a lot of heritage knowledge and kind of move on, and the knowledge transfer was done as best it could, but it was time. There was a new generation that was launching this rocket, which is our generation, right? It was the first time we got to launch something on our own, and I think this is really important because you guys, some of the current members, the last couple of launches have had some issues, right? And this was our moment where we spent a long time in the Armbrust garage building up this huge 2-stage. And when we got out to Mojave, it wasn't that we had built a bad rocket or had designed a bad rocket, but we were ill prepared to handle a 2-stage launch. We went out there, we were very ill prepared on like how to assemble something that big and that complex. And we spent about 3 hours in the launch pad, had broken launch lugs, a whole bunch of issues, and then the thing blew up and the second stage ignited. There's like technical reasons why it happened, but pretty much what happened was we went out there, we didn't realize how behind we were, we didn't realize how, I guess, I guess we didn't realize how behind we were, that's probably the best way to say it. And we got out onto the pad and had a lot of really bad issues. So the big takeaways that we have from that launch is we didn't really have any launch procedures, we didn't have any checklists. There were checklists that were made for the NASA SLI competition that we had for previous rockets in the past, but we didn't really have that as like an institutional thing. Like we didn't, the checklists that we had made, they were for reports for competitions, at least at that point on our team. We didn't use them as like functional documents, the way that like you would see that in industry. Checklists and procedures, that type of thing. And we just kind of relied on intuition because we were used to upperclassmen being able to fall back on upperclassmen who had had the experience. Now, in addition to that, we had tried a subscale 2-stage launch earlier that year that didn't go successfully, and then we went ahead to a full scale. We shouldn't have done that without a successful subscale launch. And then in addition to that, when I say we needed to take launches more seriously, we didn't do the necessary dry runs in preparation that should have taken place prior to launch day. We kind of just like went out there with our rocket and winged it, right? So COVID in that next year, going into the year 2021, both of our competitions got pushed to virtual, so we didn't have to travel, and we got a lot more time to ourselves. And a really important time in our team's history is we decided, okay, we really need to get this 2-stage thing right. Okay, there have been now 3 separate attempts at a 2-stage, both the first launch that Jesse talked about, where they had to change it last minute, and then our unsuccessful subscale, and then our full scale that we blew up. We said we really need to get this 2-stage thing right. So we went back to that subscale test platform. The reason that didn't work was because there was a issue with it wasn't operationally put together or launched wrong, but the design of the fins were a little small. It went out of angle, and the sustainer didn't ignite because the rocket was too sideways, essentially. And we decided, okay, we need to fix that, and then we also need to fix how we run launches on this team. So you can see those top 2 pictures on the right. We decided to take checklists and procedures way, way more seriously. This is something that really carried through to the rest of the projects and even up to this, like the current team of today, where we just decided we don't go to launches without being prepared. So we implemented new standards for those quality checks and launch procedures, and we spent a lot of time trying to understand the complexities of 2-stage avionics. And then we took another 3 launches in the trip in Ohio spring season in May of 2021. And on the 3rd launch, we were able to get a successful 2nd-stage ignition. And that was a really important time for our team because, like, even though it wasn't full scale, it wasn't a competition, this was just something we were doing ourselves. We were able to really right the wrongs of a launch where we really underachieved, I guess. So we were able to take that, those lessons learned on preparation, and we carried them through to the rest of our launches thereafter. So Emergence 1 and Emergence 2, which launched within like 6 months of each other, we were able to take both of those and have really, really great, fully successful flights. I'll keep moving because he already kind of talked about, Dan already talked about, kind of the history of some of these launches and everything. And before John maybe goes and talks more about the I Promise project, one thing that was really interesting is the I Promise project was the next rocket that ended up getting launched after Emergence 1 and Emergence 2, and that was unsuccessful. I promised more responsibility and felt a lot of guilt over that launch. But looking back on it, you know, I guess years later, it is really, I'm almost proud of how far our team had come, because the I Promise project, you see how big it is, right? It broke up because of a design issue. We built that huge rocket that had all of those complex, like, it was a systems engineering nightmare. But we put that on the pad with class, and it broke apart because we needed to learn more as engineers. And to me, that meant a lot, because, you know, it's okay to not know what you don't know about, you know, structures and how strong aluminum is. But it's not okay to misassemble your sustainer motor, which is what we did in the Batko launch.
To kind of touch on this, one of the key things that happened this year is the modular system was introduced. So for all those who worked on the modular system, you know what that means. Different modules were able to be put together, signed off on, and then assembled for launch. Again, you can see how many people went in support of that launch. You can see how big it was when it was standing in the jar. It was really cool, and it's a huge rocket. But the I Promise project, we went to the I Promise school over the course of 2 years and worked with so many fifth graders, teaching them about, essentially rocket science. And one of the things, maybe some people saw the bad media that existed at the I Promise school, where they were kind of talking about how the kids had done poorly in their testing. But one of the things that people don't know about the I Promise school is the way children are selected to go to the I Promise school is the lowest performing in the reading category students in Akron actually go to the I Promise school. And so being able to go there and try to offer something, a little bit of a light to these students and be like, hey, if you do get into your studies, if you do commit to this thing, there's no telling really where you can take it. And from that, we made a film. And yes, I am the person who the film kind of centers on. But the reason why is because I grew up in Kannan, Ohio, and that's right next to Akron, Ohio. And when I was in the 8th grade, I got arrested twice. My mom definitely had a great time. And during the course of that, I was actually arrested for attempted theft. And the police department actually tried to get me for, not the police department, but the person who owned the truck. They wanted to get me for grand theft auto. And I wasn't trying to set the truck, just a note. Yeah, I did that actually outside the Madison police station. So I was not the brightest kid in the 8th grade, right? Coming up in the inner city environment and just being around a lot of chaos, I was doing stuff that we did just like basically every day. And today, I work at my research center, and the primary reason for that is because I made the decision to come to, well, first go to the Army, and then second, come to Akron and join this team. And the fact that I was able to go from that position, where 14 years old, I'm sitting in a jail cell, to today, I sit in rooms where people talk about uranium, non-ironically, is kind of wild. And it's not the common story. But the real reason why it's not the common story is because the story, again, a story that goes untold is a story that goes unknown. And my friend is actually Sunless Khan for people who are into gaming. I went to high school with him. We used to like record movies in the woods. We were covered in blood, there were zombies, it was the whole thing. But he is now like this famous YouTuber, and he just donated $10,000 to the team specifically to make a film. And so I called up Blitz Studios, we put this thing together, and we ended up taking it to the Cleveland Film Festival. And then now that film is going to be released, hopefully at the beginning of 2024. We have a sit down we need to go do with the I Promise school, because most of our contacts due to attrition are no longer there. But yeah, it was kind of a wild thing to have that thing happen. And yeah, the story, again, was untold. It's the story that goes unknown. And so now, that story will be told, and it was a really epic moment. So that's cool.
And we also won a cool award at the Spaceport.
Yes, and that's 100% because of this guy. 100% because of this guy and everybody who supported him. The checklist blew the socks off of the people who were at the Spaceport competition judging. And so we literally won because of that innovation.
Yeah, it was also like a really impressive rocket to look at.
Oh, yeah.
It kind of, trumped any other rocket that was existing in that display, for the display fair. Okay, so moving on, Emergence 3, I guess this was a really important, a really awesome, this was probably my favorite memory on the team because we had, the team had run through so many challenges to get to the point of a successful full-scale 2-stage, right there. And it was kind of crazy to see all of those challenges and failed launches that we had had up to that point. This was the rocket where we really got to see it all come together. It was really awesome. There's so many people that worked on it. The way that we found the rocket was just fitting. The only thing that malfunctioned on the rocket was the GPS. So we saw it go, we saw it be successful. We saw the second stage ignition, it was super cool, and then we had no GPS on it, and it went 38,000 feet. So we were like, where is it? So we just decided, okay, we'll just come back the next morning and grid search it. And we found it 4.1 miles later across a dry lake. Specifically, Jonny Armbrust, your team president, is the one that found it. Super, super cool. It was probably my favorite moment on Rocket Team was just me and Jonny alone in the desert, screaming and banging all over the dry lake, rolling around like idiots. Anywho, so moving on, some other cool things that started to happen and kind of roll through. So I guess the point of what I'm kind of moving through is we built I think at this point we had a really good foundation, and it was just time for us to start succeeding, getting our accolades, right? So we had period 5, which was kind of similar to Emergence 2, fly at spaceport. We got second place in the 30K SRAD category. And then during this whole time, while all of this was happening, our liquid engine team was working really, really hard and ended up putting together the engine that became the first hot fire by a collegiate rocket team in the state of Ohio. Super, super cool. Moving on from that, our liquid engine team got even cooler. Specifically, a member on our team was working in Marshall Space Flight Center in their liquid propulsion branch, and got a engine donated that was additively manufactured at NASA Marshall Space Flight Center, and that had regen cooling channels and was capable of, I don't know if this number's right, sorry, I got a full-time job, I don't have time to chase down these numbers. 800 pound force, sound good? But it could burn for a really long time. Regen cool channels, really, really cool. Now the thing that was also, so moving on from that, our Venom launch vehicle evolution started to take place. So specifically that student designed engine that I mentioned in the previous slide. We wanted to take it and be the first collegiate rocket team in the state of Ohio to fly a liquid engine. A lot of those components that were used in that first hot fire, in addition to some propulsion optimizations that I wasn't too in tune with at the time. We also did a lot of weight optimization, so specifically shaved a lot of weight off, 16 pounds total off of those components to get them integrated into a launch vehicle, and then hot fired again in December of that year. Okay, so that kind of covers, our time on the team, right? Some of the things that I want to highlight is, how this impacted team budget and some of the impacts to our members. So specifically from the time of 2018 to now 2024, 2025, at the time we were getting, at least I think, I was a freshman, so I don't know, I think we were getting about 20K from the university at that time. We ended up getting nothing during COVID. But outside of that, some of these successes and I would say the productivity and the output of our team, constantly being on Akron social media, constantly doing something. Every semester we were doing something new, led to an increase in budget that is really, really impressive now. I'm really proud of the team for getting $75,000 this year. That's something that I don't think a lot of people could have fathomed just from the university. So that's just saying the University College of Engineering Department. That puts us on par with the formula teams that we never thought we would compete with. This kind of shows the overall timeline just to reinforce that point. I mean, we went from, if you look at the left side of this graph, a 2 launch a year cadence to the team was giving opportunities to students of the University of Akron to get involved on something cool every single semester, which I think should be something that we should strive for. Every semester there should be something for people to get involved with, especially because people go on co-ops and people are, I mean, I was only here in Akron half the year towards the end of it. The other half I was in Texas. That's the case for a lot of people. And if we're doing something every single semester, it gives people the opportunity to stay involved. In addition to that, now this doesn't completely encapsulate the people during our time, but something that I think is really amazing is that this team that Jesse founded 10 years ago, I think has directly impacted so many people's careers. And currently, in the aerospace industry, starting in the Northeast, we have Akronauts alumni that are working at NASA Gun Research Center or have worked at Collins Aerospace, Crane, Parker, PCC, LTA, Honeywell Aerospace. I mean, you could see all those places. I mean, Astrobotic Technology, making lunar landers, NASA Langley Research Center. That goes further into the Southeast, NASA Marshall Space Flight Center, NASA Johnson Space Center, Axiom Space, SpaceX Starbase, so many cool places, right? And then when you go out west, it gets even more extensive. Super cool space startups. But you could just see from this map that, I mean, we have Akronauts all over the country. So if you want to work in a company, it's pretty likely that either an Akronaut works there or, you know, an Akronaut knows somebody who works there. Cool.
That was Kuwait, by the way.
Oh yeah, wait, oh yeah, I didn't see that. Yeah, we also have an Akronaut in Kuwait. Yeah.
Saudi Arabia.
Yeah, there it is. Yeah. Cool. Okay, so lessons learned in closing, I guess maybe some big notes to take away for the current members of the team. Oh, I put animations on the slide, nice. Okay, cool. All right, the red is me. You know, I think get as much hands-on experience as possible. I don't really have to say much more about that, but the team provides that. You don't get that in your classes.
For me, unseen work accomplishes little, prioritize storytelling. Like I said, an untold story is an unknown story. So tell your story. You should be making it all. Just
So something that was really important to me and that I've expressed to, like, you know, some of the people that are still on the team now is, you know, generally on the team, you know, the team has a lot of members, but, you know, there's people, every project that's successful has about, you know, 3 to 5 people that really, really care about it. That's not to say other people don't also care about it, but that's to say 3 people who care about and own a project will accomplish more than 30 people who don't. So when you're building these complex projects, find the people who are willing to sacrifice their free time, sacrifice times even with their families, to be able to put these things on the pad and see them successful. Find those people and work through them instead of, I just think that's the most successful way to do things. That seemed to be the way we found the most success.
Incorporate senior design projects into existing team plans to avoid conflict. The project logo year, again, Charles's infamous graphic, really beautiful. Beautiful. It was a fun time. Incorporate the senior design projects into things that you're already doing. If you make a senior design project the center of what you're doing, and it's the thing that you're doing, you're bound to fight. Like, it's just objectively true. Because if that senior design project is picked for the big thing, and then the other ones don't, then you start arguing about money, and happy marriages fall apart over arguing about money. And while we all like each other, we don't love each other that much, right? So, well, some of us do, but not everybody.
Cool. And then my last note that I think is really, really important is when you fail, it has to affect you. You have to take it personally. You know, it's okay to have productive failures. It's okay to blow up rockets. It's okay to even embarrass yourself. But if you don't care about it, if it doesn't like keep you up at night, you know, you're just going to repeat the same mistakes over and over again. So I stress that because, you know, you know, as you guys go into the future, if you guys start blowing up rockets, it's okay, just as long as it affects your mental health severely. That's all.
Okay, so impossible today equals inevitable tomorrow with the right mindset. And And so the reason why all these things really happened is because a few of us got together and dared to dream big. It was absolutely ridiculous to sit at the University of Akron and say, we're going to launch a rocket to space. We're going to have the best liquid engine program we could possibly have in Ohio, while Ohio State is buying rocket engines from Aerojet Rocketdyne. Like, what? All of it was impossible. And it became inevitable. Just by shifting the focus, shifting pieces around the chessboard, and figuring out which moves were the right moves to make. Figured that part out. And yeah, you'll be able to do anything. Literally. Send stuff to space. The CubeSat idea is phenomenal. It's pinnacle.
Okay, so the last thing we have one thank you slide that is for a few people that have been very, all of this, like, we talk about increasing launch cadence, that takes a toll on, people that aren't on our team, and we want to recognize them. So specifically, Chris Pearson, Steve Eves, and also the Armbrust family. Thank you guys so much for, during our time on the team, sacrificing your free time and your homes to be able to help us. We definitely appreciate it. Good. Look at that retro picture I found of Chris. I was so happy. I was like, dude, he looks so cool. Yeah. All right, thank you guys. We specifically didn't mention any names because there's too many names to mention. But we appreciate everybody that's on the team with us. This is us getting to present a lot of people's work. So awesome.
Big time.
Thanks, Brian and John, for the introduction. Kind of impressive. You only went 26 minutes over your 15-minute allotted time. Two of the most long-winded people I know, and doing a presentation together, kind of incredible. It was only that much. So this will be, in comparison, a tad bit shorter. All right, so we heard the beginning of the team, we heard the continued history of the team. Now we're here for the where are they now. My name is Jonny Armbrust. I started off as an infrastructure lead on the team, and then I became the team operations manager. Today, some people call me the president.
And my name is Diffendal. I started on the team only 3 years ago, which is kind of crazy. Started as a structures member, moved on to being the design team. From that sub-team kind of shifted. Now, somehow chief mechanical engineer up here. So we're going to be going through the history of the team from here, and then the present and the future, where we tend to take it. And we hope it can go in the next 10 years, 20 years, and on from there. So a little bit of a timeline of where we've been over the last year and a half now. Ryan touched on Imperium a little bit, but I kind of want we'll move into 2024, which was, especially in the spring, was a very big year for us in terms of launches and hot fires. As you can see right there, 2 hot fires, 4 launches, actually 3 hot fires and 4 launches in the spring, and then we look for more in 2025 as well as we move forward into this spring. So there we go. All right. Well, they touched on Imperium a little bit, so we won't go into that too much. But kind of starting off with our ISL rocket, a lot of.
Is this working?
As we proceed to get bigger and larger and trying to fly higher with these rockets, especially after the success of Emergence 3, we started to realize that some of our components needed to be tested for higher altitude launches. So specifically starting off with a couple of low altitude tests to be able to have the proof of concept, especially for our chroma, our flight computer that was manufactured here, that was designed here, for E4, also used for spaceport, and was going to be used for BOV. So we decided that an ISL rocket would be necessary, launched at the farm in Amherst, Ohio, flew to about 2,000 feet. Unfortunately, due to a lack of sealing, because of not sealing off the motor bay, we didn't have a drogue deployment and main caught, but didn't have enough time to inflate. But that did give us some crucial data that we needed to carry in to the next couple launches that we had, which again led us into, I guess specifically VOB, but the next three, so Emergence 4 and Spaceport as well that year.
So next up was the VLB Hotfire. This specific one was the third in the system, was in the flight configuration. And I'd like to say that this was probably one of the most important hotfires that we had. Dabbling in liquid engines is not something that you do as a rocket team. You're either all in and you're all out. So at this point in time, we had started with something, we had something good, and it was time to test, it was gonna work in the flight vehicle. So it was an extremely ride or die and make or break moment for the team. And as you can see from the data on the screen, we hot fired it during one of the colder months, which dealing with nitrous wasn't the greatest idea because it has temperature properties that put out a lot less pressure at colder temperatures. But anyways, we received 250 pounds of thrust for about 12 seconds, and giving the conversion into what that would be in warmer temperatures, the team decided, hey, this is a viable system that we could put into a flight vehicle and launch for the team. After that hot fire was successful, we took the data, we put the team together, and we decided to make a flight vehicle, aka the VLB launch vehicle. This was also a really huge moment for the team because it had taken the group of people involved in liquids, and really only in liquids, and it merged them into the people that worked really mainly in structures. So not only was it a technical challenge on multiple levels because we hadn't done something like this before, and the entire state of Ohio hasn't done something like this before. So there was definitely a lot of clashing of ideas, a lot of big personalities butting up next to each other, which I'm sure a lot of people are familiar with at this point, but it's something that's unavoidable on a team like this. When you're trying to break records, when you're trying to be better than everybody else, you're gonna run into issues like this. But at the end of the day, the team was able to come together and put something together that was pretty great, honestly. I personally wasn't able to make the launch, which is a little bit sad, but here the team is at the launch. We achieved 10,000 feet, which is pretty bang on with a lot of our simulations, and 350 pounds for roughly 12 seconds. So a huge accomplishment for the team. It was the first liquid engine launch in the state of Ohio.
And I also want to add that continuing off of Ryan's weight optimization that he talked about earlier, the big push for the team going forward as we continue to move higher has been weight optimization and overall just trying to get these rockets as light as possible. So one way that happened was through taking the aluminum and steel fin and compressor fin cans that we had been dealing with for a while and trying to find a situation that could lighten those up even more. And that's kind of where we came across tip-to-tip layup, and that's where our composites team was born. I do want to add that composites is a fairly new team, sub-team to the team in general. It's been around for about 3 years. I know some of you guys were able to see it on the tour. But between our tip-to-tip layup and bringing back being able to wind our own tubes here on campus, it has been a massive step in the direction of weight optimization for us beyond the accessibility of metal components. So this was the first flight of our tip-to-tip layup system, something that we had been developing for 2 years up to this point. So I'd gone through a couple iterations working directly with Collins Aerospace, their materials, being able to work with their autoclave, things like that. Was also kind of an outreach moment for the team. A lot of younger members being able to reach out to the company, being able to work with their materials, work with their engineers, really figuring out a way to weight optimize this to a point where we had viable numbers to get it off the pad. So along with the impressive and fantastic feat of the engine, this rocket was pretty marvelous engineering feat overall for us. So leading from that, we kind of led into our next liquid engine build, which was
Project Stinger. So what do you do after you just launched the first liquid engine in the state of Ohio? Well, you make it bigger. So Stinger was a project that was essentially the goal to make as much thrust as we can within a reasonable level. So we set an arbitrary goal of 2,000 pounds. It was achieved through using LOX and ethanol pressurized with nitrogen. Nitrogen was just the easiest thing that we could get on hand. This picture in the bottom left-hand corner is during the first hot fire date, April 20th. The second hot fire put out 2,000 pounds, reached steady state for 23 seconds. The goal was 40. However, there was a liquid oxygen leak right around the back of the engine in this zone. So we were able to remotely shut down everything. This was something we hadn't dealt with before. We didn't know what could happen. Could it have blown up? Could it have been fine? We weren't sure. So we shut it down, everybody was safe, and then we went for a third attempt right afterwards, which had a small controls sequencing error, and we ran a little engine rich, which if you're not down on the lingo, it means we were burning the stainless steel out of our engine. The second picture on the right here, this was at the second hot fire attempt. I just merged them together, even though they're separate dates. But this time we said, hey, our impinging injector works, our system works, the feed system works, so let's try a different injector design. And our very own Seth Arkwright put together a Diffendal and machined it himself. This design put out about 1,300 pounds for the full 40-second duration. This, to our knowledge, is the longest burn time of a liquid engine by a collegiate team in the country. So, correct us if we're wrong, but that's pretty darn good.
So alongside, while VOV and the Stinger hot fires were going on, and we were working with that in the turbine building, we also had another solid rocket being built on top of that. So kind of carrying from the ISL rocket some of the test data that we got, we wanted to take the fourth iteration of the Emergence series past that 38,000 feet goal that we had hit with Emergence 3. And hoping to shoot for 100,000 feet. Now we had simmed 100,000 feet. We ended up having a goal of about 75,000 feet with over Mach 3, which made it the first Class 3 rocket that the team had ever launched in their history. As I said before, with these higher rockets, higher apogee rockets, the weight reduction efforts and just component optimization was huge for the team and still carries on. In the end, the rocket flew to about 55,000 feet. Again, it was a two-stage 6-inch to 6-inch motor, so it was a little bit different from the rockets, the two-stage rockets we had flown up to this point in this series. But 6-inch to 6-inch flew to about 55,000 feet before having a stage separation failure, where the sustainer motor ignited before separation caused overpressurization of our sustainer motor. We did end up recovering bits and pieces, not very much unfortunately, but the booster and the sustainer both were 152 millimeter diameter angular string motors, combining for around 80,000 Newton seconds of total impulse. So it was a pretty impressive feat for the team. Still was the newest apogee goal for the team that we had hit, passing that 38,000 feet. But yeah, so as we move forward into the Emergence series, this was a big milestone and a big learning curve for a lot of us on the team, as I would say that the team is a little bit younger now than it's been in the past, and for that to be able to be seen and taken from and learned from was very valuable for most of the members here. Now, the great thing was we had a rocket. We came back from this launch, we came back from Emergence 4, and we had 16 days to turn around, build another rocket, and take it out to competition. So we got back from E4 on May 28th, and we turned around and left for Spaceport on June 12th, something around the time of that. We were competing in the Spaceport 30K SRAD category. They don't have two-stage categories, so just 30K SRAD. At the competition, this trip was a little difficult for all of us, as not only the short turnaround, but also just nothing seemed to roll our way in terms of travel. Thanks, Manny. If he's still here. We blew 2 tires. Sorry for calling, yeah, that's what that story is about. Calling you overseas. We blew 2 tires on the way down. We had a couple of problems. Our motor had actually been shipped down to New Mexico and had been residing in New Mexico, so this rocket's booster motor had to be built the week of launch, which was obviously something that is not ideal and we haven't done before. We also dealt with significant weather issues. We were supposed to launch on Wednesday. We ended up launching Saturday morning because of just weather pushing us back, cloud coverage, things like that. But this rocket, with that same COTS motor, ended up being our kryptonite. It ended up being a COTS motor failure right a couple seconds after launch. The top 2 grains actually ejected out of the motor. But this rocket, along with Emergence 4, quick back-to-back turnarounds were big learning curves for us, especially as I mentioned, a young team. We were still placed 2nd in the 30K category in our technical rating, and then we placed 5th in the 30K category for the build, design, and quality, which was a major success for us. Again, considering we only had a little over 2 weeks to build this rocket, being able to place 5th. I think we were 30th out of 140 teams in that competition for design quality. It was a pretty impressive feat and something that we hope to carry into the future. So again, the booster and sustainer statistics are listed there, but we flew a 4-inch to 4-inch motors, but we flew a 6-inch body to a 4-inch body. So all of these rockets, this experience, 4 rockets, 2 hot fires jam-packed into a couple of months, was a pretty crazy experience for all of us. But that didn't really stop the initiative to keep climbing, to keep growing, and eventually that carried us into projects that we have today, the projects that we're moving forward with, and projects that we've been working on and we'll be launching throughout this first semester. So, kind of starting with Emergence 5, so touched a little bit on Emergence 4. Emergence 5 will be a similar build to our Emergence 3 rocket, in the case that it's a 6-inch to a 4-inch booster to sustainer. We are working this time around with a larger booster motor. It's going to end up being an 117-inch tall, 6-inch in diameter booster motor that we are static firing motor propellants for to figure out, try to get a longer burning propellant. Angry Listerine is still the backbone of the team, but we are looking into longer burning propellants right now. So that's kind of a cool R&D experience that our solid motor team is experimenting with right now, almost every weekend. We also are looking with these higher longer burning propellants at a higher apogee between hopefully 200 to 300,000 feet and over Mach 4. So in the end, it's a pretty crazy time to be here. It's crazy seeing even where I was able to start, get into this rocket now, seeing what the members are putting in. That initiative really hasn't stopped. It hasn't slowed down. If anything, it's sped up, and it's been able to climb even faster to the point where we are now. So, you know, I personally, we still have 2 more rockets to go, but thank you guys to everybody that's put time and effort into this team, building it into what it is now, because being able to do this and being able to have more hands-on experience with the team has just been life-changing for, I know, so many people, and seeing it now, and who's coming through now and who's going to be able to take it to where it will be in the future. So, again, building off of that, Spaceport kind of stuck as the competition that we want to go to, with some Spaceport drama this year. It's no longer Spaceport, it's back to Iraq, with an unknown launch location, which is fantastic. But they opened up the competition to a 45K category, so we're hoping to launch in that 45 2-stage category against, I think there's 7 other teams in the competition right now. But that will be, again, a very similar build to Project Eric in terms of we were very close with what we wanted with Project Eric, and we wanted to take it back, similar build, the high design quality that we had, switch out a couple motors, make sure that our motors are sound, and take it back. So, again, the big thing has been our composites team. We're looking to wind our body tubes to be able to fly on this rocket. We also are looking for this rocket to just be, on top of that, fully SRAD, so building, machining all of our components in-house, winding all of our tubes, mixing our propellants, and then on top of that, obviously payload is the big, the big attention grab for the rocket competition. So they're looking to do a modular head, mechanical arm payload, which will be pretty exciting to see. So, yeah, moving on to the last but not least of this year.
All right, last but most certainly not least is the liquid engine rocket that will use Stinger Block 2 as its method of propulsion, a regeneratively cooled, traditionally machined liquid oxygen and ethanol pressurized with helium mockbuster. So mockbuster is going to be 12 inches in diameter. Hopefully we're going to be able to wind all those body tubes in-house. Everything has been machined in-house. The predicted apogee is a whopping 400,000 feet. And most notably, we're going to be launching this rocket at a $1 per foot competition with Friends of Amateur Rocketry. Meaning, if successful, in conjunction with all their technical parameters, if this is a successfully recovered rocket, we will be earning $1 for every foot of apogee above the rail. So this could mean wonders for the rest of the team for the coming years. If we're able to provide that level of funding for the team, that level of success for liquid engine, it would be absolutely amazing. This is going to be posing one of the largest challenges that we've had on the team. It'll be another interaction between structures and liquids, butting heads once again. But this time we've been there and we know the issues, so hopefully we'll be able to find different ways to solutions. So this is our last project for the year. This is where the team's going. Hopefully you all have been able to see everything that we've scaled from beginning 10 years ago. I mean, it's incredible to hear everything that Jesse had to say and everything that John and Ryan had to say, and now the things that I'm telling you, it feels kind of crazy. One of the biggest challenges along the way, aside from everything technical, for me at least, I've noticed in my years of leadership has been the turnover of knowledge. Whereas Jesse was struggling to get the basics down, now we have such a wealth of knowledge between all of our members and all of our leadership that it's getting difficult to teach everything to the newer members so that we can carry on that knowledge and build it. It almost feels like there might be a ceiling of how much they can teach someone in 4 or 5 years before they graduate. So that's one of the hugest issues that we're dealing with as a team currently. And there's obviously many ways to go about it. We can broaden our people who we're bringing onto the team. We can have mentors, mentees. There's tons of avenues to take on this challenge, but it's one that's big with the team.
So with that, that's all that we have for tonight in terms of the newest projects, and that I can bring Dan back up for the rest of the presentation.
We are now going to recognize 9 individuals whose dedication and impact has helped shape the team into what it is today. Now, you're going to hear me say that a lot coming up here, but trust me, I mean it every single time. So, let's get started.
Pretty obvious one. So, the award for Akronauts founders. So, this award will go to the 2 co-presidents who started this team 10 years ago. This award commemorates all of their hard work, determination to get the team and its first rocket off the ground. It is my great honor to present the award for Akronauts founders to Jesse Batko and Kenny Smith. Thank you so much. And so to Kenny Smith, so we are recording this whole thing. To Kenny, we will mail this to you, or get this to you next time we know how. We'll contact you either way. So, next up. Oh, there you go. So, next up, we want to give an award for our founding advisor. This is the other pretty obvious one. So this individual is greatly influential in guiding the team through its first years, and the team will always be thankful for this individual's contributions. And I don't think he's here tonight, but we'd like to present the award for founding advisor to Dr. Francis Loth. And again, to Dr. Loth, we will get this to you as soon as we can. Next up, we want to give the award for a team mentor, and these go to two particular individuals. These two individuals have guided our solid and liquid propulsion programs for many years. And it is their dedication, their patience, their teachings that helped our propulsion programs blossom into what they are today. We are very lucky to have these two individuals as our team mentors over the years. And with that, it is with great pleasure that I present the award for team mentor to both Chris Pearson and Steve Dees. This particular Akronaut was on the team from fall 2015 and on through spring 2017 and even around the beginning years of the team as well. And in these years has helped create the framework for how this team operates, especially in its early years. I don't want to skip over and spoil the surprise. So, and they've particularly bringing in members from a variety of majors, not just in engineering, but beyond, with computer science, with media, with business, everything. So, with that, the award for Everlasting Impact goes to Danny Dippolito. Please come forward. To a beneficiary. However, this individual has contributed far more than just simply donations. From her hard work as a recovery lead, guiding the team forward, and eventually propelling the team forward as team president, this recipient has left a tremendous impact on the team. The team is extremely thankful for everything this alumni has done. And I don't think she's here today, but I would like to present the award for Outstanding Benefactor to Victoria Jackson. Get this to you as soon as you can. And finally, we have our final awards. The award for ongoing support. This is going to two recipients who have done so much for the team, both before and after they have graduated. From reworking Zion in the span of 5 days of competition, to letting the Akronauts camp in their yard and build the team's most powerful rockets, their never-ending dedication to the team will always be remembered, and the team is immensely thankful for them. It is my great honor to present the award for ongoing support to Lucas Bloom and Anna Tabazzi. all of student union staff and crew for helping get this event to how we dreamed this to be. I don't think we could have asked for a better event. So I want to thank all the student workers that are here, Kelsey that's works downstairs, and everyone in between who worked this union to get this all together. So first off, thank you to them. Next up, real quick, I want to thank the catering staff for the cash bar and the catering and the delicious food we had out there. You guys are amazing, and it's very delicious, and definitely going to make a difference after this. Thank you very much. And finally, everybody at the University of Akron. So the College of Engineering, deans, faculty, professors, mentors, everybody in between. Also a special thank you to Stephanie, Ayla, Julie, and Jordan, and everybody else that I forgot to mention. Thank you so much for your support of the Akronauts over the past 10 years and continued support going forward. We're very, very thankful to be part of this amazing university, and yeah, we love the University of Akron. So thank you all very much for those of you here. Thank you. Now, here we go. Time to thank everyone who's helped make this event possible. Every single person, whether you've helped for about 10 seconds or all the way since April, is when this whole thing was conceived. But before we get on with that, I have to give a special thank you to my partner in crime, Riley Myers. You and I have been going back and forth this whole event since April, and especially this past fall. And if this really, if you were not here and part of this event and working so hard to get this whole thing to happen, we would probably not even be standing here today. So thank you, my partner in crime, Riley. Thank you so much. All right, and now the big thank you. I'm going to have to read this one off. So now here comes the part where if you've helped in any shape or form with this event, this is for you. So I'm going to read off every single name. So here we go. Sam Dillenbeck, Eric Hartman, Ana Clesia Alice Almeida, Johnny Armbrust, Nami Whitman, Eric Diffendal, Dale Chenoweth, Colton Luca, Trevor Davis, Dominic Salupo, Aiden St. Clair, Blake Dillner, Chris Tomei, Jesse Batko, John Davis, Ryan Dippolito, Emily Armbrust, Danny Nicolito, Anna Tomasi, and finally, Hannah Adams for being absolutely amazing, providing so many photos and videos of our early years of the team. And thank you all. Thank you all. Thank you. Now, one more group of people that I have to thank, and then we'll wrap up for this evening. And so, this one I'm definitely going to go on the script that will yap about this. So, when this team was founded 10 years ago, I don't think anyone would have anticipated the team winning so many awards over the course of the past 10 years. No one would have guessed the Akronauts would be the first collegiate team in the state of Ohio to launch a liquid fuel rocket. And no one would have even thought that the Akronauts would launch, including subscales, 27 rockets over the course of 10 years. I don't think anybody would have guessed it. Now, to the alumni that are here, and to alumni that will watch this recording in the future, this event and what we have for you all today, the rockets on display, the banners, the presentations, the shirts, the food, everything, this is our gift to you, and it is a symbol of our gratitude to everything that you have done for this team. The research, design, manufacturing, testing, documentation, successes, failures, sleepless nights, blood, sweat, tears, good memories, bad memories, stories told and untold. All of it. We are truly thankful for everything you have done for this team. Your effort and discoveries have influenced every single rocket we have launched since your time. And it is all of your work that has propelled the team 10 years later to be one of the most powerful collegiate rocket teams on the planet. We hope that this gift that we have for you tonight brings you all a happiness and gives you a sense of pride in what you have achieved and your work that made these beautiful rockets fly. And as the years go by and we all get older and more gray, everything that you have put into the team, every single bit of it, will never be forgotten. So, with all that in mind, We want to thank every single Akronauts alumni for everything you've done for this team. Whether you were on the team for 1 month or 6 years, I want to thank you all here, and thank you everybody who will watch the recording in the future. And I also want to thank you all, not only for your work, but also for your time and attention tonight. And we will be open to take more photos of the Rockets, as well as get more drinks in the cash bar for around here in the evening. And besides that, I wish you all safe travels on your return home, you eventually go home. A happy Thanksgiving, and a farewell. And I will see some of you in 10 years. Thank you all for everything, top to bottom, and everything between. Go Zips, and good night. Thank you all.